We will be doing 3-1 representing relations, and hopefully you've watched the other video that deals with all of the vocabulary. A relation is a relationship between two sets of data or groups of numbers. A set of ordered pairs is what we use in math to compare the domain and the range. The domain are all possible input values or x values of a given function. Range are the output values or the y values for a given function. A relation can be represented in multiple ways. We can have mapping where the domain is on the left and range is on the right. How do I know that the first one is the domain? Because if you look at this arrow, it points towards the range. The table, the x's are on the left, the y's are on the right. X is down here, y is here. And then an equation. Remember, it's in y equals mx plus b form, or if you have it in standard form, it's ax plus by equals c. Okay, so if I have this right here, I'm going to make a table. My x's and my y's. These are my x's. So I have 2, 0, 3, negative 3. Then my y's. I have 0, 4, negative 5, and negative 5. So 0, 4, negative 5, negative 5. So then I plot my points. 2, 0, 0, 4, oops, 1, 2, 3, 4, 3, negative 5, and negative 3, negative 5. And then if I was doing my mapping, I actually like to go in numerical order. So negative 3, 0, 2, 3. And I have negative 5. I have 0 and 4. So negative 3 was going to negative 5. 0 was going to 4. 2 was going to 0. And 3 was going to negative 5. And there we go, I mapped it. So what is the domain on this? The domain are the x values. So negative 3, 0, 2, 3. The range on this would be negative 5, 0, 4. So the relation of this, we put it in an ordered pair. Negative 1, negative 5. Oops, I should make this bigger. Comma, 4, 7, and negative 2, 3. So my domain, I like to do my lower number. I should have put D. And 4, I like to put my range. And that's negative 5, 3, 7. Here. My relation, I have negative 2, 1, 2, 3, 4. Negative 2, negative 4. I have negative 1, 3. And I have 1, 2, 3, 4, 5, 1. My domain on this would be negative 2, negative 1, 5. And my range on this one would be negative 4, 3. Oh, I'm going to do 1 and then 3. Oh, that was silly. 3 and then that. The relationship, or the relation for this one would be 1, 5, 5, negative 1, negative 6, negative 1. My domain on this one, I don't know why I keep forgetting to do this, would be negative 6, 1, 5 because I like it in numerical order. My range on this one would be -1 and 5. Okay, the next part, independent values. Independent are the domain. Okay, so that means, oops, it's right here, our x value. Okay, then our dependent is the range, and it's usually the y value, and it depends on what the x value is. So if I look over here, my dependent would be time. Almost always, I did not mean to write dependent. Okay, and this is no, try that again. Try that again. This is independent. I don't know what I'm talking about. This is dependent. There we go. So over here, it says the graph represents the number of text messages sent to Nora throughout the day. Identify the independent and the dependent variables of relation. Already did that. Describe what happens in the graph. Okay, so if I describe this, I'm looking for the highlighter. Here we go. If I do this part, that means that as the time is going, the text messages sent would be a lot. And then here, we don't have any text messages happening. And then this, slowly we get some more. And then here, we stayed the same. And then we keep getting more and more. Or sorry, I should say, we're sending more and more. Okay, so identify the independent and dependent variables on this one. Okay, so our independent variables on this one, the average ticket price to the museum park has steadily increased over time. So time is our independent variable. Dependent variable is the average price of the ticket. Next part, the independent variable on this one, the average or the air pressure inside a soccer ball decreases with time. Time is still the independent, and the dependent is the air pressure inside a soccer ball. Okay, so this one says, after airplanes take off, its altitude increases rapidly. Once it reaches the desired altitude, so it went up rapidly. So it went up rapidly. Once it reaches desired altitude, it continues to fly at the level of for a short period of time. So it stays here. Then the plane's altitude fluctuates slightly, not a lot, due to turbulence. So something's happening, and then it decreases quickly as the plane lands. So which one kind of looks like that? Now, B and D have fluctuations, but it says slightly. Right here, where was it? Oh, fluctuates slightly. This is dramatic. These are dramatic. So right here, B would be our answer. Okay, Kane notices the traffic congestion on his street. On weekday mornings depends on the time of day. He draws a graph represents the relationship between the time of day and the volume of traffic congestion on a street on a work day morning. Analyze the orange segment. Okay, the orange segment is right here. So it's going down. So as the time goes, it's going down. Okay. The congestion is steadily increasing. Well, it didn't increase, so it's not this one. The traffic is a constant and very light. Well, it's not constant. That would be a straight line. is constant and very heavy. Well, it's not constant. It's decreasing, so this part is D right here. Okay, and by the way, this part would be A. B would be here. Oops. And very heavy would be C here, just so you know. Okay, this next part, when the coordinate system, when graphing on the coordinate system, the scale of the graph refers to the distance or interval between each tick mark on the X and Y axis. Okay, make sure that you know the scale of the graph. How much are the X and Y axis going up by? So if I was to look at this right here, I want to look for what is the highest and lowest of the X values. So I'm looking at the X values. I have a negative 36 and the highest is 38. So I'm going to need to go from at least, what, negative 40 to at least a positive 40. Then if I'm looking at the Y values, the lowest one is a negative 91, and the highest looks like it's an 80. So we're going to need to go from at least negative 100 to a positive 100. Okay. The x-axis should include value. Oh, sorry. That's good to know. Go away. I apologize. I was doing the one from down below. Oh. Okay, so the lowest one was negative 36. The highest one was 38. So if I did interval notation, it's from negative 36 to 38. Y-axis is going from negative 91 to 80. So my notation would be negative 91 to 80. Okay. What do we want our scale to be? Well, let's look at this. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, oh, so that's 16 on both sides. So could we go up by 2s? No, look at, let's see. 2, 4, 6, 8, 10, 12, 14, 16. That's not going to get it for us. How about if we went up by 4? So 4, 16, 18, nope, try that again. 4, 8, 6, 12, 16, oh my goodness, 20, 24, 28, 32. Nope, can't go up by 4s. Maybe I need to go up by 5s. So maybe going up by 5. So 5, 10, 15, 20, 25, 30, 35, 40. Okay, so that would get me negative 40 here, negative 30 here, negative 20, negative 10. Okay, so now I need to do the y-axis, and I need to get down to negative 100. So I'm thinking, can I do 5s? Let's see, 5, 10, 15, 20, 25, 30, 35, 40. Nope, that'll only get me to 50. So maybe I'm going to have to go by 10s on this. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this one down here would be negative 100, negative 80, negative 60, negative 40, and negative 20. There we go. So I'm going to say that we did by 5s on this one, and we did 10s on this one. Okay? Now, so I have 580. So 580 would be up here. And then it says negative 3648. Negative 3648. So it's going to be past 35 and almost to 50. So negative 50, I mean. So about there. So then 25, negative 91. So 25, negative 91. So that's going to be just past 90, negative 90. Then we have 38, 95. So 38, close to 40. And 98, close to 100. Then negative 10, negative 50. So that one's easy. And 122. 122, so somewhere about here. Okay? So here. So when graphing this, what would our interval notation be for our domain and range? So our lowest number is here. Our highest number is here. So for domain, our interval notation would be, oops, I did not mean to do that. Negative 10 to 16. Our range, let's go over and look at our range. The lowest number is negative 27. The highest number is 32. So the lowest number is 27. The highest number is 32. What would I scale by? I would say x-axis, I would scale by 2's. And y's, I would scale by, I don't know, I guess we could do by 3's. Oh, I should say what I would probably go from negative 20 to 20. And this I would go from negative 35 to 35. Maybe go by 5's. I could do 5's here. I would do 2's or 4's depending. Okay. When choosing the appropriate origin, you will start at the point 0, 0 as the origin, but changing what it represents. So if I look over here, I'm looking at the years for my x values. So my x values on here are the years. But we're not going to do years since 0. We want to do the years since this very first date. We want to do since 2005. Oops, I should say years since 2005. Let y's represent, let's look right here, total snowfall in inches. So total snowfall in inches. Okay? Okay, so 0, 0 does not stand for year 0. It's standing for 2005 and 0 inches. Oops, I don't know why I put inches. And 0. Interval notation for the years. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 years. Interval notation, the smallest we're dealing with is 0, and it's going to go up to 43.3. It's actually 1. The lowest is actually 1. What would be the scale for in inches? 43, so I have 1, 2, 3, 4, 6, 7, 8, 9, 10. We have to get up to 43. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I think we would go by 5s. 5 inches. Okay, down here, it says social media, the average number of posts per day on social media site each year is given in the table. Interpret the meaning of the axis, the scale, and the origin corresponding data. So if I look at this, what does the x-axis represent? Years since 2008. Where did I get that? It says it right there. What does y represent? Average posts per day, per day, in the millions. How much does each tick mark represent on the x-axis? 1 year. And the tick mark on the y-axis, 50 million. Because it says it's in millions. Okay, what does the origin represent? It represents the year 2008. I guess I could say that year 2008 and $0 million. Oh no, not dollars. Silly. Posts. Okay, so down here, what does the x-axis represent? It's going to be right here. Years since 2001. What's the y-axis going to represent? Circulating coins produced, and that's in the billions. How much does each tick on the x-axis mean? 1 year. And for the y-axis, 2 billion coins. I forgot the N. Coins. What does the origin represent? 2001 and 0 coins.